Okay, so gravitational potential energy, and I'm going to talk you through the definitions. All right, and some of these definitions I don't like. I find them very vague. Um, and the one that I really don't like is the definition for energy. Energy is the ability to do work, and it's just not clear enough, especially you young ones. So that's something you've got to know. And what do we mean by work? And the kind of picture I have is if I want to change something, if I want to squish something, or if I want to make something move faster, or if I want something to slow down, I've got to provide energy to do that. I want to cause a change. Any change that we cause requires energy. I think that's a very, very tough concept. And I think the definition is just a little bit too vague for people who are new to this topic like you guys. All right, so gravity. And again, you'll read this, it's the force that pulls towards the earth. And we've got to be very careful with that because a lot of students will turn around and say, well, gravity pulls you down. And I don't like that. I'm going to tell you why. This is the earth. And if we picture ourselves stood somewhere and we go, right, which way does gravity pull you? And you go, well, that way. Well, that's really not true. Because then you have people who call Australia down under. And if you're stood in Australia like this, if you have this picture of downwards, you think, well, why are people not falling off the earth in Australia? The reason being, it is key to understand what we mean towards the earth and how we can actually be clearer about that. And what we mean is towards the center of the earth. Okay, that's what we really mean. Let's just move that so we can understand what I mean by towards the center of the earth. And I'm just going to pop that up here. What do I mean by towards the center of the earth? Okay, and what I mean by towards the center of the earth, irrelevant to where you are on a object. In this case, we're on a planet. We are being pulled towards its center. So it doesn't matter if you're in the UK or if you're in Australia, you're being pulled towards the center of the earth. So that's something I want to be clear about because a lot of descriptions in books are very vague and very misleading. Okay, so what is gravitational potential energy? Right? It's the energy that's actually stored in an object, literally because about how high it is away from the ground. All right, the higher it is, and so I've got this kind of idea, picture in my head, and the picture in my head is, and this is very important, you must have a picture in your head, is that the higher an object is off the ground, for me, it tends to be a water balloon, the harder it's going to hit one of my friends. Right? So if I drop a water balloon out of a window, the higher the window, the harder it's going to hit the ground. And that's the idea of gravitational potential energy. Before I let go, it has the ability to hit the ground very hard and go splat. It hasn't done it yet, but it's that potential to do that because of its height above the ground. Okay, so the formula is very easy. It involves height, which is always in meters, right? Mass, which is always in kilograms in physics. I'm saying that in physics. In chemistry, it's grams. In physics, in kilograms. Gravity. This is the force that which gravity pulls you down, and it is 9.8 newtons per kilogram. Yeah, you can round it up to 10 newtons per kilogram. Newtons per kilogram. Right. Weight. I'm really not going to talk about weight. Because it's going to be too much information. We've done it before. I've mentioned it a while ago, but I will come back to it. So the thing that I want to be key about is energy transfer. And energy transfer, and we look at energy transfer pathway. So what's happening and why am I doing GPE and kinetics? So I'm going to talk about me when I was younger. I was a little bit of a naughty cheeky monkey. This is a water balloon, and there's the university at window. University where I live. There's the window. There are my friends down here. and I'm going to drop a water balloon on them. Now, up here, there is gravitational potential energy. The energy to potentially do something. And as it drops, it changes. It changes from gravitational potential energy. Down here, it is moving. It's lost height. Height is changed. So, for example, if it was 2 meters off the ground, by the time it's down here, it's really 1 meter off the ground. So its height has gone down. Its gravitational potential has gone down, and it's gone from not moving, where its velocity is 0 meters per second, but don't worry too much about the units, to moving quite fast down here. So this is the energy transfer, the energy change. It is changing from gravitational potential energy to movement energy or kinetic energy. All right, and this is really key. Now, key idea: gravitational potential energy is the energy an object has because it is lifted above the ground. When you lift an object, you do work against gravity. All right, my son, who's a bit older than you, he's year 11 now, was helping me build a log cabin. And when you lift the wood above your head, you are working against gravity. And we call that gravitational potential energy. We've increased the gravitational potential energy. If it falls, that gravitational potential energy is changed to kinetic energy or movement energy. All right. Now, this line came out really dodgy. To calculate gravitational potential energy, I write as E, GP, gravitational potential energy, is equal to mass, always in kilograms, times height, always in meters, times G. This is always, for you guys, 9.8. I'm getting used to 9.8. A lot of people use 10. I don't like it. You need to get used to using things like 9.8. Okay, so here are your questions, all right? And you've got some pretty meany ones going down here. All right. Let's stop recording.